Elon, he wants to send people to Mars. Like, cool, do it. What are you going to do with them when you get there? What does your logistics trail look like to keep them there alive?
Today I'm chatting with Sandy Magnus, former NASA astronaut who didn't just visit space, she moved there for 4.5 months, living aboard the International Space Station and logging 3 shuttle missions across her career. Sandy has also served senior roles in the US Department of Defense, including as the DoD's Chief Engineer for Advanced Capabilities, and as Executive Director of the American Institute of Aeronautics and Astronautics, the world's largest aerospace industry technical society. Sandy's work spans the entire space ecosystem: human spaceflight operations, satellite communications, defense applications, and the economics of turning low Earth orbit infrastructure, lunar mining, and Mars logistics into investable businesses. So where are the real opportunities in commercial space? How soon will the moon become a profit center, not just a flag planting exercise? And which technical and financial barriers still separate us from routine Mars missions? I'm Ben Kaplan with Deep Venture Partners. As always, our email is deepshow@deepvp.com. And let's go deep.
Sandy, maybe as a starting out point, I think you're the first person I've ever known who's lived on the International Space Station. What is the difference, just for those who don't know, the difference between going on a shuttle mission to space and actually becoming a resident of space, which you were?
Yeah, I tell people that I moved to space for 4.5 months, and there's a big difference. I had 2 shuttle missions, one before my long duration mission and one after. And when you're on a shuttle mission or a short-term mission, you have a very packed timeline. It's like running a sprint. There's things you need to do. There's a certain amount of time. Your head's down getting your mission done. When you live in space, it's a much more relaxed pace. It's more like a marathon. You adapt at another level. You have more time to enjoy it. You understand it better. You understand how to move around in microgravity a lot better. So it's apples and oranges. They're both great experiences, but it's apples and oranges. They're way different.
How does that change your perspective?
The big perception shift is when you separate yourself from the planet and you can look down on it as not being a part of it. Because human nature, we take advantage of things that are around us all the time. We take things for granted. For example, I live in Washington, D.C. There's all these wonderful museums that are free. I don't go there until I have visitors who want to go there because it's there. It's in my backyard. I take it for granted. So we take the planet for granted in the same way because we're on it and it's in our, we're kind of in its backyard the whole time. But when you separate from the planet and you look down on it, I remember in my first mission when I opened the payload bay doors, and I saw the Earth from space for the first time, it was like a brain to mouth moment. And I looked out the window, I'm like, oh my gosh, our atmosphere is so thin. I mean, it's just this thin layer of air, right? That's blanketing our planet to keep us alive. And you know that intellectually because you can do the math and sort it out. But to see it, that experiential knowledge is completely different. And so you really look down on the planet like, wow, it's so fragile. It's a spaceship. We're all in it together. That's when astronauts come back. They talk about, you don't see borders and things like that because you see the planet as one unit that we're all a part of, and we're all engaged on it together. We're all interacting with each other. We're all affecting each other. In my mind, the more people who can get up there and they can have this change of perception about our planet and what it means to be a person or a species or a human that lives on this planet, I think the better off we're going to be because it's so easy to take it for granted. And you look at it from space and you realize, wow, this is a really special place and it's really fragile.
You've served on advisory boards for, companies like Virgin Galactic. What are the biggest opportunities? What are the biggest risks of human commercial spaceflight?
Well, I think the opportunities are that more people can experience space. And we're actually at that point where our vocabulary has to change with respect to experiences in space. And we can go there if you want to. But having more people experience space, again, they have this perception shift, even if it's just the suborbital flights that Blue Origin has been doing, that Virgin Galactic will hopefully start here in the next year or two. You get that perception shift and it makes you feel different about the planet. So the more people that have that, the better. the more people that can engage in space, I think we'll grow and mature as a species. So that's a huge opportunity for us, right? You think about the Apollo 8 picture of Earth from the moon that changed our perception enough about the planet that created the environmental movement. We're on the cusp of that next step. The danger, though, or the risk is it's still very, very on the advance of what we can do as humans, and there will be issues, there will be problems, there'll be accidents because it's still very, very dangerous, and it shouldn't be taken lightly. And I think the people who work in space are very, very aware of that. As more and more people get into space, whether they're aware of the risk that they're taking or not, that remains to be seen, but it's still very risky.
What would have to advance to make space travel like air travel?
There's a lot, the propulsion systems, there's a lot of work that goes to prepare these rockets for launching. Even, the Blue Origin rockets, the shuttle, the Dragon, the Boeing, all of these rockets, the Soyuz, there's a lot of work that goes into making them safe for people to fly on. And the companies and governments are working to try and reduce the amount of work by making these systems more and more safe. But they're for example, for commercial airplanes, there's a set of standardized safety measures and safety regulations, both in how you build a piece of equipment and how you operate the piece of equipment, that everybody who flies passengers has to live up to, no matter where you are in the world. We don't have anything like that for commercial space yet. We're still at that sort of like 1940s, 1930s place where we're with airplanes, when for a while people didn't even realize that seatbelts were important, right? So we haven't got a set of global standards on what it means to fly safely with respect to, customers and passengers. Like I said, the companies are doing jobs, and it's in their best interest to make sure that they're flying people safely, but there's no, global consensus on a set of rules and regulations and operational principles that are so standardized that anybody can do it. It's still very much the cutting edge.
From the point of view of commercial entities that want to push forward technology or the human condition, but also want to turn a profit, where is the opportunity, or how do you analyze it from like an investor's point of view?
No, you look at what SpaceX is doing, what Virgin's trying to do, what Blue Origin's already done, what Boeing's, working its way towards. Those companies understand what it means to build a vehicle that's safe. NASA has published a lot of information over the years. They have a set of human spaceflight standards. So they're out there, but that sweet spot, as you talk about, is that Venn diagram between safety and profit, right? That's really what I think we're still trying to work on as an industry. I mean, Bezos is self-funded. Elon has some investors, but he also has a lot of government investment. And so they're trying to sort out where is that line between safety and profit. And they're doing well. What we're not, when you think about this, the airplanes where they're taking off, thousands of them every day, hundreds of, tens of thousands of them all over the world in a regular cadence. And it's very, very systemized. We're not there yet.
You're saying that we would need to make the unit economics work out. It sort of works out on this one-off. We're trying to advance a company. The company has a market cap, a stock price, and it goes up when they're successful. But to actually have reoccurring travel that is profitable and safe, that is a whole other realm that we have to work out the economics of.
Right. And that's what they're working on, right? That's what SpaceX and Blue Origin and Virgin and some of these other companies, they're trying to work on that. And Elon's all about trying to up the cadence of his flights, right? And understand and what is that trade-off and what processes do you need to put into place to make sure that as you up the cadence, you maintain the safety. So this is the kind of the holy grail that they're all going after, but we're not there yet. We're still learning.
Is this next 20 years in space? I mean, is this an era of collaboration? We're going to all work together and the human condition to sort of do more and get there? Or is this going to be an era of intense competition from what you've seen from talking with some of those players who are in, some kind of commercial space race?
Well, it's a little bit of both, right? I mean, at the government scale, you'll see collaboration and competition. Companies, they're very good at understanding where they need to collaborate and compete based on their business model. So I don't think it's going to be one or the other. I think it's going to be a little bit of both. If you look at the people who are doing the human spaceflight side, it's very, very much in the entrepreneurial area. Yeah, like I said, you've got Bezos who's self-funded, and you've got Elon with a goal. I mean, his goal, as he stated, is Mars, but he's got some funders. He's got, but it's still private. He's got a lot of government backing. So there isn't really. Virgin went via the SPAC. They tried to set out a SPAC. I don't really know how well that's going. I haven't talked to them in a while, but they're manufacturing some updated spacecraft for purposes of safety. So they're still, it's all out there. Everyone's trying to sort it out. I think you'll see both competition and collaboration wherever it makes sense.
You brought up Elon Musk a few times. What is his role in all of this? Because he seems like, this past year, such a lightning rod for every discussion, whether it's space or politics or the Trump presidency or everything else. Like, how does his role in this have a play, and how reliant is the U.S. government on SpaceX right now?
Well, I guess one thing I want to say is a lot of credit for SpaceX's success needs to go to Gwen Shotwell. Elon's in the news all the time doing whatever it is that Elon does, but Gwen has been running SpaceX for a very, very long time, and she's brilliant, and she's done a wonderful job with developing that company and keeping it looking forward and just making a lot of progress. So I really want to give a shout out to Gwen and everything she's done over there at SpaceX. As far as the U.S. government, the U.S. government made a decision after the Columbia accident that it was time to retire the shuttles. And then they made a subsequent decision that instead of investing in another low Earth orbit crew vehicle, we were going to count on the commercial industry to show up with those kinds of capabilities because of as we talked before, the advancement of technology, the advancement of the knowledge of what it takes to do operations in space. And so SpaceX and Boeing won those service contracts. And at the moment, SpaceX has been very reliably flying astronauts to the space station for the last, 6, 7, 8 years. Boeing has flown one crew, and they're contemplating what to do with the next launch. So we have currently to the space station the Soyuz. We still fly an American astronaut on the Soyuz. The Russians fly a Russian cosmonaut on the Dragon, and we have the Dragon. So the U.S. government is fairly reliant on SpaceX at the moment until Boeing, crosses the plate with their vehicle to get people to the space station.
Well, and so do you worry about all of the kind of political, it doesn't have a lot to do with space, but just a lot of like back and forth, we oughta, President Trump saying we ought to rethink government contracts that are going to SpaceX and the back and forth. Do you, as someone in the space industry, worry about that, think that will have an effect? Or do you think that's like all bluster by, big players and big personalities?
Well, I can't begin to guess what the heck is going on with some of the statements that are getting thrown around out there. But I can tell you that in the space industry, we're better off, NASA and the government space program is better off when they have a plan that crosses multiple administrations, because it takes a long time to do the things that we do. We think about going to the moon now, right? And going on to Mars. You just can't do that in a 4-year time frame. So you have to have consistency of policy and consistency of vision. And so the more that gets disrupted, the worse it is for the whole industry because of the timelines involved. And we've been pretty lucky. We've had a pretty consistent vision for what the plan is since 2010. And so it would be really counterproductive for that to get disrupted when we're on the verge of achieving some of the goals that we set out a decade or so ago.
We've been 20 years from Mars for Sandy's entire career because propulsion isn't the bottleneck. Logistics infrastructure is. The moon isn't a detour. It's the only realistic testbed for supply chain models, autonomous manufacturing, and operational cadences that will decide if Mars stays science fiction or becomes economically sustainable. It's Everest Base Camp in the stars, unglamorous, essential, and where most of the hard work actually happens.
How do you think about AI, robotics, the future of space, that maybe a lot is done without humans in flight or on board, or is that sort of overhyped or not?
No, it's been a debate that's been in existence since I've been working in the space industry, for 3 decades. And it's not an either or, it's an and, right? Because there are things that humans do better than robots. There's things that robots can do better than humans. And some of those gaps are actually, potentially closable with AI and VR. But there'll still be, I think things that humans will do better. I think the best design you can have for a mission is using the strengths of each to complement each other. Whatever those turn out to be as we continue to evolve our technology. I don't think you can completely replace robots and AI with humans. But I think how we'll use them will change as we build those tools a little bit more.
What was an example of when you were on the space station or on a shuttle mission of something that you think you were doing that probably a future astronaut would not do, or a robot would do? And then something where, is there something else that you hope you're still doing, even though there's talk about, maybe that being off-sourced to a robot or something like that?
First of all, one of the things that we need to do as we build vehicles that go to the moon and Mars is we need to, take advantage of computational power, AI, whatever you want to call it, and build smarter spacecraft. So, for example, when I was on space station, 2008, 2009 was my mission. Every 30 days, I had to sample the atmosphere. I had to sample the water. I had to do surface sampling. It's just because we were doing environmental monitoring, because it's a closed system, right? And you want to make sure that everything's staying in alignment. And I had to do acoustic signatures. I had to do radiation signatures. So having a spacecraft that can do its own environmental monitoring and then just let the crew know when something's off that needs some attention, that would be super helpful, because it was just ridiculous. Oh my gosh, we can't do this as we're going to Mars. The spacecraft has to be smarter. And then the other thing is the space station was built to have a whole system of people on the ground monitor, the battery state of charge, where the solar arrays are, the thermal system, the motion control system. And so you want a spacecraft that can take that kind of ground monitoring that we do now, and it does it all itself and only alerts the crew when there's something that the crew needs to take care of. So that's hands down, the way we need to start building spacecraft. And so what I still expect to be doing, daily mission things, some of the science experiments, you'd have to still have a pretty dexterous robot to do some of that. And then for some of the experiments that we were doing, I was actually on the video and the audio with the principal investigator, and we were altering the experiment during the experiment based on the things that we were finding. So it wasn't, do the experiment, analyze, come back, change the experiment. It was a real-time kind of loop. And there was, 2 brains involved in that. And I think that's something I would expect humans still to do. And some of the mission planning, some of the knowing the goal and then understanding how to bring in all of the variables and find the right path, that takes, for an AI, that takes a lot of machine learning, right, to give you that matrix. But as we're going out further and further, there's going to be a lot of unknowns that we don't know, that you can't necessarily program into a machine ahead of time, at least at this point. So I think there's still going to be the need for the human brain involved as we go forward.
I know you've advised companies like Bridgecom on developing optical wireless satellite technology, the future of satellite communications, satellite networks, especially if we need that for, both here on this planet, like climate monitoring, for instance, or we need some kind of monitoring of a mission going to Mars. What is the kind of opportunity risks in kind of space-based communications? Yeah,
so there's a lot of people are working on optical communications. it has a lot of potential. I think, the security aspect is certainly important. How you maintain secure comm links. That's, we can have a whole conversation on cyber and some of the challenges there. The technology around, or the mission planning around, where do you put the satellites? Where do where the signals need to go? How do you do the relays? What's the cost benefit ratio of that? What do they look like? There's still a lot that has to be worked out there. From the viewpoint of putting a communications network around the moon, or even thinking about Mars, again, who's the customer besides the government for some of that? As you think further out, around the Earth, you could probably come up with a lot of different business cases, but going further out into deep space, who else besides the government is the customer? Does the government really understand what architecture they need? These are all the questions that people are working on right now.
And when we've chatted before, you've talked about market development for something like, I don't know, mining of asteroids or things is that what it becomes? Like, how do we transition from the government as a sole customer and funding of everything to something else that has its own market dynamics, industry? Is that a big leap we need to make?
Yeah, and that's a hard one, right? And in low Earth orbit, people are figuring out, you've got, Wi-Fi from space, communications, Earth imaging, these kinds of things have been happening for a while. But when you think about in situ resource development on the moon, or solar power beaming, or asteroid mining is probably the one that has the most immediate market development, even though there's a lot of capital that you need to put into. We're not there yet. But manufacturing in space, right? Who are the customers? Even commercial space stations. NASA's looking at, hey, we want to rent time on a commercial space station. It's like, cool. How much time do you want to rent? How do the people who are going to provide a commercial space station close their business case? Who are the other customers? What are they going to do? And so this kind of leap is what the industry is really struggling with right now, is how do you make that leap? What are the business cases where maybe you can use the government as an anchor customer, and how much of an anchor customer can they be? And then how do you fill in the rest of that pie? And, people are looking at, I want to build a rover and take it to the moon. And so NASA's funding commercial companies to send rovers to the moon, which is great. And, one company's been successful and a few others are getting close. Now the government's funding that. So who's your commercial market for that? Who else needs rovers on the moon, right? Or if the government's thinking carefully, how can they start helping to develop a market? So for example, commercial space stations, right? It's hard for people to understand microgravity unless you've been in microgravity, right? It's a difference between intellectual knowledge and experiential knowledge. But, fluids do amazing things in microgravity. Surface tension takes over. You see astronauts with little bubbles, of water all the time. I had water glove on my hand. And you get up there and you get someone like Don Pettit, who's a colleague of mine, brilliant natural engineer, natural scientist, very creative. You get people like that in space and they can get into microgravity and go, oh, I could try this, or I could try this, or I could try this. And that's how you're, I think, going to get market ideas, right? You get brilliant engineers and scientists, creative people up there, and they experience the environment, and it starts activating their brain cells. And then companies, they can tell their company, hey, I've got an idea. We can do this in microgravity, and maybe it's a place to go. But, the government has to figure out how to seed that, right? That's another reason why getting more people in space, I think, would be really helpful, because people can experience microgravity and have that experience and then translate that into whatever their particular area of expertise is and go, oh, now I've got an idea.
Is that literally, you feel this is something you can't intellectualize, or you can't go on the VR simulator and sort of get the gist of it? You really have to do it to get at someone who's done it many times?
I'm not going to say that there aren't people on Earth who can't make that leap. It's easier to make that leap if you experience it, because it's pretty amazing, right? Look up wherever you're sitting right now. Look up and imagine yourself on the ceiling. Imagine yourself moving around that room and putting your body in any position. Imagine yourself, if have you ever had to fix your sink, your plumbing, like
sure.
under your kitchen sink?
Okay,
right?
Sure.
Okay, so you're getting under the sink, right? And you've got a wrench, maybe two, and you've got your body contorted on the floor, and you're trying to find a place where you can see what you're trying to do and you're trying to hold the wrenches and the wrenches are running into stuff and it's like super awkward. If you were in space right now, all you had to do would be flip so your feet are facing the ceiling and you'd just be reaching right into the cabinet. And it'd be super easy.
Everything would just be instantly easier for this task that I have.
As you approach the task right now, your gravity's holding you to the floor and you're approaching the task the way you've always approached the task because you have no choice. You don't realize that you have a choice. In microgravity, you have a choice. Another example, space station, right? The engineers designed the space station. Where did they put the lights? On the ceiling. Because that's how you put lights, right?
Sure.
When you're living with every surface being the floor or the ceiling, you need lights everywhere. But nobody thought of it because you're thinking sort of like gravity induced, right? So it does make a difference.
Do we need more space entrepreneurs who have actually experienced space? Living in microgravity isn't just floating. It's rewiring every assumption about your earthbound brain makes about work, rest, and geometry. Astronauts don't just adapt, they internalize physics at a visceral level. That experiential knowledge is why Sandy argues more entrepreneurs or business people in the sector need to experience space. You can't brainstorm microgravity business models from a conference room in Palo Alto. According to Sandy, you need to feel it to invent it.
What do you think the impact is, like, from your perspective on just life on Earth, from the discoveries we make in space? I mean, there's a long list of everything from, memory foam to freeze-dried food to, certain water purification systems to different solar technology that all comes from the space industry. But where do you expect new developments? Where will there be new products, markets that are the next generation of items that sort of come from space that we use here on Earth?
Yeah, a lot depends upon where we go with this moon exploration. But I think from a low Earth orbit viewpoint, there's a lot of potential in pharmaceuticals and biology and areas like that, biological engineering and biomedical engineering and things, because we're learning, we learn a lot about the human body up there. And because there's, in microgravity, there's no gravity, you can learn a lot more about very small things, because the surface tension takes over and gravity doesn't hide a lot of phenomenologies, and we learn more there. And so there's a lot of great work going on in that area. I mean, the asteroid mining, Blue Origin, Bezos started Blue Origin with this idea of getting all heavy manufacturing off the planet, right? That's what his original vision was. And you think about the idea of trying to mine an asteroid and get some of our resources there instead of stripping it out of the Earth, I think that will have a huge effect. But the technology that we're developing continues to be applied as it comes down, as we advance what we need to do to go further and further into space. That technology keeps getting transferred. So I think those are areas, at least commercially, when we get to the moon, and they start figuring out how to do this in situ resource utilization on a big scale, or do additive manufacturing for things that are bigger than the machine, because right now additive manufacturing, it's all a lot of it's in the machine. And I think some people are working on that on the ground, but in zero gravity, they're looking at how do you build a truss in space with additive manufacturing? How do you take regolith on the moon, process it, and then build something with it? Those are techniques I think that are really super intriguing. But I think it's all about using the resources that we find in space to do the things that we want to do in space, because getting things off of the planet is very expensive. And if you can use the resources in space to build things, or even create logistics chain that's not related to Earth, then you've really changed the economics of the whole problem. And so that's what some of these people are doing.
So not so much that we'd bring it back to Earth or something like that, what you make there, or would it, or more just like what you need in space, you build in space?
That would be ideal. That if you really want to change the economics, that's where you need to go, right? Because getting something out of the gravity well, or even if you could send raw materials up, that would be much easier than sending some of these exquisite systems that we need to keep people alive. But yeah, Making things in space from the materials that you find in space is a huge, huge differential.
You've worked in the defense sector as well. I mean, what is the interplay between like R&D that should be done at the government level, R&D that is like at the, peer research university level, and sort of like, I don't know, civil or commercial deep space propulsion systems? Like, how does that all work together? One of the recurring themes on this show has been like, investing in research, and then there's a certain phase where it needs to be commercialized also, but some of it's just pure research. So where do you see that in sort of space, that overlap, government, university research, commercial contributions? How does that work together in the next 20 years?
Well, hopefully it'll continue to work the way it has, but maybe a little bit more efficiently. So here's the thing, like the government, and I have this whole chart that I show people about, the role of the government versus the role of the commercial sector. So government pays for things, government shouldn't be making a profit, right? That's not their goal. They're supposed to be investing in the future, creating new sectors of the economy, among all the other roles that they have. But so the government should be investing in R&D that's very basic, that can be shared widely so that people can look at it, companies can look at it, creative people can look at it and go, oh, that's really interesting. I could go do X with it. And it's available because it's government funded, right? So that kind of R&D, the government, and the government can decide if it wants to do, 5-year timeline, 10-year timeline, 15-year, 20-year timeline, depends upon the area, right? Some of the research requires a lot more time, but that's what the government should be doing strategically. So once the industry's starting to, creative people, let's just say creative people, wherever they are, right, are starting to think about applications, again, that bridge is, where's the market? So sometimes you can go straight into a commercial market with some things. I mean, I'm not talking space now, I'm just talking general, right? But in the space sector, we think about the moon and the commercial low Earth orbit. There's enough understanding out there in the world at the moment, and it's been happening for the last, after 50 or 60 years of work, because the government's invested, there's enough understanding about technology, what it takes technologically to work in space, what it takes operationally to work in space, the safety, all the trade-offs, that these people, Elon, Jeff, these others, started getting into space. Or college students are launching CubeSats. College students are building and launching CubeSats. I couldn't have done that when I was in college. So that knowledge has been out there because the government has, been investing in this area for so long. And now finally entrepreneurs are like, cool, maybe I can do something with it. And that's happening in low Earth orbit, and it has been for the last decade or two. We're still very, very young there from a human spaceflight viewpoint, but commercial's been doing it. So now NASA's taking that bubble, I'm just using NASA as an example, is going to the moon, right? And now they're going to the moon. Now there's a whole nother set of technology, that we have to sort out because a lot of the Apollo stuff is gone. And we have to sort out. Now, if I'm doing it intelligently from the government viewpoint, and I'm really trying to create a market, and I'm really trying to understand how to leverage commercial, and I'm really trying to understand how to build a system in space, I have to figure out what things should I contract out for a service, or what things should I pay to develop? Because if I'm paying someone to develop it, I can take that IP and spread it around. If I'm paying a company just to show up with a widget, that IP belongs to the company. But I can do that in areas where it makes sense, that if there's a commercial market that I could seed and they have the IP, that's actually very helpful. But if we're doing new things that we don't really have a lot of knowledge on, then I want to be able, as the government, to get, develop that knowledge and make sure it's available for everybody else, right? And so that's the ecosystem that we need to keep working on as we go to the moon and Mars, is understanding very strategically where to invest in commercial to allow them to have the IP that they can use it for other potential customers, and what would that look like? And where do I need to invest in commercial, but be able to take that knowledge that we get from developing that new technology and spread it so that other people can use it and multiply it. So that's really what that whole pipeline should look like.
And have we done a good job of telling the difference between the two up to this point, or have things got mixed up and we got it in the wrong bucket and then it was hard to extract it?
I think we have like a C. It's not a bad thing because we're all learning, right? When you get into a new sector like this and you get into things that we haven't done before, or developing markets like this, you're going to have some winners and some losers. You're going to learn. You're going to have to fall back. You're going to have to switch a little bit. So, I mean, we're muddling through.
Okay, so there's not a overall master plan we're following, but we'll iterate to get to the plan over time.
That's humans. That's what we do.
To be a viable U.S. space company, you need multiple potential customers from a list including NASA, the U.S. Department of Defense, the European Space Agency, and commercial options. Having just one or even two of these potential customers introduces a lot of risk. Smart Capital is now asking, can this company survive if NASA's budget gets cut by 30% in 2027? Having multiple viable economic channels can be a deciding factor in separating real businesses from science projects with a pitch deck.
Sandy, I want to end on something we do on the show from time to time, which is kind of like a true or false round, an overrated, underround, kind of short answer questions. Just get your take on it, if you wouldn't mind. And they're all going to be topics you're well versed in. First one, true or false? By 2040, we will see the first human colony on Mars. True or false?
False.
Why?
We've been 20 years or 20 to 30 years away from Mars my whole career. What people don't understand is you can send people to Mars. I mean, like Elon, he wants to send people to Mars. Like, cool, do it. What are you going to do with them when you get there? What does your logistics trail look like to keep them there alive? Are you going to how much are you going to be able to use the resources of the Martian surface? Are you going to have to deliver water? Are you going to have to deliver food? Do you have a closed loop life support system that works? How are they not going to be bored? What are you going to do with them? I mean, human colony is anything from like 2 people to 20 people, right? But the logistics is the hard part.
True or false? Space tourism is a distraction from serious scientific missions.
False. That, a statement like that implies that space tourism is the only thing going on. It's a part of the sector. All the other people are still doing their thing. It's not, yeah.
Artificial intelligence will never be a better crewmate than a human in space.
Based on what I know now, true.
It just can't duplicate what a human would provide.
Yeah, based on my experience, it's hard for me to picture where AI is going, but human beings are very social in general. Even introverts like myself, we're still very social. And I just wonder what a year without a human would be like, even if it's an AI. I mean, I can't see it, but that doesn't mean like 30 years from now, somebody like, well, why did she say that? That's so stupid.
Okay. And finally, true or false? The biggest threat to space exploration is not technical, but political or financial.
True, in spades.
Why? And you say in spades, you don't hesitate. Why?
Because it's always been a political problem. Like it's a perception. Like I said, NASA needs a constant vision. And we've been fortunate for the last decade and a half, we've gotten that to this point. Financial, everyone thinks we spend so much on NASA, but think about, if you pay $1 in taxes, right? So about 60% of that dollar goes to entitlement programs. Another 25 to 30% goes to defense, and the rest is discretionary. Probably another dime and now goes to paying off the national debt.
Yeah, sure.
Right. And the rest is discretionary funding. And that's everything, not just NASA. So if you take out the NASA piece of that, they probably get maybe 0.7 of a penny out of that dollar. So, if you're serious about space exploration and you're really trying to invest in the future, or if 0.7 of a penny for every dollar you pay in taxes is not a lot. But there's this perception that we spend a huge amount of money on space, and it's that much.
Well, which brings us to overrated or underrated. Space missions can help fix our problems here on Earth.
It's true. I think it's underrated on all levels, right? The technology we're advancing, the collaboration. You talk about the international collaboration that happens in space. It's actually super important to help us understand how to work together. The operations even that we're doing in space they help us understand how to work together in teams and even practical things like telemedicine. I mean, it's all very helpful. We're curious as human beings. We explore as human beings. Exploration helps us break down barriers and learn new things and advance, our capabilities. So I don't think that you can underrate the importance of all that. We're not stagnating.
Overrated or underrated? The moon is a stepping stone to Mars.
I don't think it's underrated. I don't think people appreciate how important it is. And let me just go back to my commented about the design of the spacecraft and how it needs to be more self-contained. That's an operational shift from how we've operated in low Earth orbit. The moon is only 3 days away. So it's like our backyard. It's a great testing ground, not just for the technology, but for the operations. And go back to the logistics, understanding all of the intricacies of logistics. Even in low Earth orbit, I don't think people understand how much logistics goes into just supplying the station and keeping track of the things that you need to put onto the station. So the moon is definitely a stepping stone. Now, the people who would argue against that are very afraid that we'll go to the moon and we'll settle and we won't go beyond that, right? That's the argument. People are like, no, you got to go straight to Mars because the moon is a distraction. But if we go back to the strategic thinking that I talked about before, about how does NASA design a program where you can go to the moon, you can use commercial, and if you're doing it correctly, you can set up an infrastructure there that as the government continues to expand that bubble to Mars, there's an infrastructure that's left on the moon that the commercial community and the commercial market's capable of taking over and doing something with, similar to what's happening in low Earth orbit, right? So if you design it that strategically, you could minimize the possibility that we would just go to the moon and get stuck there, which is what the naysayers worry about. It's complicated. It's, we're talking not 2 years or 5 years or 10 years, but I think that a program like that could be designed.
Maybe it almost sounds to me like, I don't know, like people who climb Mount Everest, there's like a base station there, and that base station kind of, lots of people, a lot happens at that base station to enable the sort of the boulder treks up the mountain. It sort of sounds like that to me.
That's actually a really wonderful analogy, and I may borrow that from you.
Okay.
And when I'm trying to explain this in the future, but you have to be able to practice in your backyard. And if you get to the point where we know how to build things in space that we're going to use in space, that just makes getting to Mars a lot easier, because the gravity, getting things out of our gravity well of Earth is really expensive, really risky.
Final couple last ones here. Overrated or underrated, the value of asteroid mining. Game changer or science fiction?
It's a little bit of both, right? I mean, I think it would be a game changer because there's a lot of rare earths and other kinds of really important metals in the right kind of asteroids that would be really, just super beneficial to be able to mine. The science fiction part is finding those asteroids, understanding how to get to those asteroids, extracting the materials, figuring out what to do with the materials. That's all non-trivial. Now, mining companies, interestingly enough, can work on decades scales, right? That's how they mine on the Earth. So there are mining companies getting interested in this kind of a problem in space, but they've got a lot of the robotics, because there's a lot of robotics that operates in mines. So they have the techniques and things, but translating that all to space, finding the right asteroid, is it near? Is it far? How do you get to it? These are real problems. So I go both ways on that question.
This one's submitted by our staff. Sex in space is fundamentally different. True or false? I'm sorry, I have to ask you, Sandy.
Okay, I have no idea from personal experience, clearly. However, I would suggest that the people who ask that question look up Newton's laws, because when you live in space in microgravity, Newton's laws rule your world. You live by Newton's laws. You internalize Newton's laws. So one of them is, an action, you exert a force and the force is exerted back to you. So just take that thought, extrapolate it, and figure it out for yourself.
Okay, very good answer. And finally, the Space Force, U.S. Space Force, underrated or overrated as a concept? Do people understand what that means? Underrated, overrated, U.S. Space Force.
Yeah, so it's underrated, right? And I had a lot of people, why are we doing this? So here's the deal. So much of what the military does is in communication systems, all these things assets they have in space. So the Navy had assets in space, the Air Force had assets in space, the Marine Corps had assets in space, the Army had assets in space. And so it makes sense, from an efficiency viewpoint, to bring all of the parts of those different communities that were building assets in space together so that they could work together and have sort of, a scalable system and an intermingled system. And so the Space Force does that. It takes those people, those communities that were, thinking about how to use space and kind of puts them together and makes it a little bit more strategic. And I don't think when people think Space Force, they're thinking Star Wars and Star Trek and things like that. And it's really much more simple than that. It's like communications and how for the different tribes to work together.
So like anything else in government, breaking things out of silos where they can't be communicated about, let's put them together and sort of unify that. And that is the fundamental value and purpose.
Yeah, there's a lot of logic to that.
Just putting on your investor hat for a second, as an investor, we have a lot of investors listening. Where would you look at? What would certain sectors, industries, markets, what would you look at as potential for if you wanted to invest? You're excited about space. Maybe you dreamed of being an astronaut. We didn't realize it like you did, Sandy, but you'd like to do something with space. Where would you invest or put time and resources now?
Well, I think communications, some of the optical communications is really interesting. That's going to be a thing. We've got a lot of people looking at Earth imaging. I'm not sure I know what the market is there, but that's probably worth looking at. You've got people who are trying to do internet from space. Keep an eye on what NASA's doing in the moon program and what you might be able to dual use for that, or even triple use, military versus commercial versus civil, those kinds of technologies. If you're a long-term investor, find out what the mining companies are up to. That's actually something on my list of things to do, is go find out what the mining companies are doing. That's way long-term. There's people thinking about solar beaming. I don't know if that makes sense, beaming it from space to Earth, but, perhaps a moon application. You want to look at those things that NASA might be needing from the commercial industry that could be leveraged for a civil market later in space.
Sandy Magnus, what a fascinating life and experiences you've lived. I could actually chat and ask you all kinds of questions all day about this. Thank you so much for joining us on Deep, and we can't wait to have you back again.
Thank you for the invitation. It was a fun conversation.
This episode has been brought to you by Deep Venture Partners, an emerging venture capital fund in Silicon Valley. Get show notes, transcripts, helpful links, and more at deepvp.com.